Hello. Uh, I hope you can see me well, you can hear me well. The microphone is configured a little bit differently, so if you have some problems with the sound, just message me in the chat. Yeah, there's the first question: will I become an expert after watching this? You will definitely become an expert. All my webinars, not all of them, but the last year, maybe even a little bit more than the last year, they're all dedicated to object-oriented programming. And this one is the webinar number 38. So I've done 38 webinars over the last 2.5 years, or let me check when I started. No, maybe 3 years actually. The first one was in 2015. Yes, in April. So now it's what is it? October 2018. So we are doing this for 3 years. But I started from webinars which were dedicated to different subjects, different topics. They were about programming, about management, about architecture. But now, for the last year, I'm focused on object-oriented subject only inside webinars. For the management topics, you should listen to my podcast, which is called Shift M, and you can find it on the blog. Just check the top menu. There is Shift M link, and you will be able to hear that. There's no video there, but pretty nice interviews and discussions about management. So the webinars are all about object-oriented programming, and today I will talk, you will listen, and you will ask questions if you want about parsers and parsing, which I covered in the blog post. I think it was, let me check, it was like a year ago or so. It's quite old already. No, it's not a year. It was like in February 2018. So it was less than a year ago. And I suggested in the blog post that we should use, when we need to parse something which is coming to us, we need to use a little bit, not a little bit, but a different approach from what we traditionally use. We know this is this design pattern which is called Parser, and this is what I'm suggesting to, this is what I'm arguing against. There's somebody's asking in the chat, why Ruby? I'm mostly Java developer, but for the last, I think for the last half a year, I'm writing mostly in Ruby. Not because I decided to abandon Java. I love Java a lot, but Ruby looks like a simpler and easier and shorter, less verbose language for me. And small projects I write in Ruby. Small experimental stuff I write in Ruby. And let me start with the example to demonstrate you what I mean by this parser thing. Let me start with an example. I'll show you two classes which I created in two different projects, and which are doing actually very similar things. Well, first of all, before we get into my code, let me show you how usually people do stuff. Okay, let me first demonstrate the problem I'm going to solve, what the code is for. So let's say I have a piece of text, just a plain text, a string, and I want to convert that text into another presentation. In one case, it's hex numbers. So so if there's something like that is coming, let me increase the size so you can see it better. If, let's say, hello world is coming, then I want to translate it to, I don't know, something like that, some numbers. So basically it's a job of a translation or parsing or pretty similar, pretty simple stuff. So how would I do it traditionally is something like that. Numbers, parser, convert, right? That's a pretty typical, or maybe sometimes even parsing utils, convert to numbers. That's what I believe you can find in so many places, in so many libraries, in different languages. We just have a method which converts what's coming in into what we need in the output. we can convert, we can I don't know, create some MD5 hash. We can convert to we can lowercase, we can do uppercase, we can do capitalize, we can do parse, JSON parse, we can do what else, XML parser, parse, I don't know, command line options we can parse, like options parse, and then the command line options, and many other things. They all work pretty much the same. We have some parser, which is basically a static method from a utility class or from just a class, and then we call that method and we get the result back. What I'm suggesting to do, and I'll just jump into an example first before we discuss things. I'll show you that. I'll show you a good example first. This one. Here, I needed to take the piece of text and convert it exactly to hex presentation. So that would be, this is the unit test for it, and how it works for me. Look, this is the text. I'm just testing how it works. How are you? And then here's what I'm doing. I hope you follow. So in order to create the hex, I am making an instance of a class which is called hex from text. In Java, that would be hex from text, this way. It doesn't matter. In Ruby, it's the colon. So this is the name of the class, which is a presentation of the text, which I encapsulate in the constructor in a form of. So here, hex would be something like, I don't even know what it's going to be, but I can run the test right now, and I will show you what exactly that hex is. Let me run it. You're not going to see the console, but I will just, I'll do it fast. I'm running the test now. Okay, so here it is. So that's the presentation, the hexadecimal presentation of the text, how are you? Because here I'm calling the, let's make it even better. So this is the object, which is a hex for the text it encapsulates. It's not yet a string. It will become a string when I call toS. toS is like toString in Java, same in Ruby. So when I call toS, it returns the string it has to return. And then I convert it back. How do I convert it back? I create another class which is called hex to text. So this one was from text, and this one I called to text. And again, I let's call it reverse, or I don't know, back. Let's call it copy. So now I again create an object which is a parser, obviously, but at the same time it is a representer of the text. It is a representer of the text, and it encapsulates the hex. That it looks quite elegant to me. This is I found that solution. I found that, not design pattern, but that approach just about a month ago. Before that, I was not doing that. I was not, I was always trying to find out what's the right way to parse back and forth when we have something some piece of data which is, for example, coming from the network, and it's a JSON, and we need to parse it somehow and represent as an object, and then we need to return it back and represent it back as JSON again. So it always needed some sort of a combination of parser printer, like two different classes, which would be not the right approach. And or I was trying to put everything into one class, and it still didn't look elegant. I'll show you how it's done in another project, almost the same operation in Zold, in our, in the cryptocurrency we're developing right now. It was a similar problem to solve. But here it was a little bit different. So we want to take a piece of, we want to take a number. We take a number n. You see we're testing with different numbers here. We take a number and then we define how many hex digits the result has to contain. And then we print that stuff into the string. And it will, for a different number, it will represent different text. And then we want to take it back. We want to make a copy of it. So how do I make a copy? I actually was using the static method parse, which I didn't like for years, but I was doing it still. So one way, in order to preserve, in order to maintain the entire functionality that deals with this parsing and printing, to maintain it in the same place. That's what I wanted to achieve, to keep everything in one place. I did the printing inside the 2s method, but the parsing I had to put it to static method, because where else? Where else can you put the parsing stuff? And that's how the class looked. So that class, you initialize with the number, and then the 2s, formats it the way it has to format it to print the digits. And then if you want to take it back, you call self parse, and it somehow parses the text and then returns itself. You see, it returns the instance of this class, encapsulating the numbers which were just managed to parse. So this static method returns an instance of this class. It's not really elegant because, because it's a static method. You know how much I love static methods. I think I don't love them. I think that static methods are a big mistake in object-oriented programming. But that was, for me, for years, sort of a legal case for using static methods. Until I found that approach, which now looks to me absolutely brilliant. So we have one class, hex, and we have two subclasses, which are, one of them takes the text and and makes the string. In this case, it's quite primitive because it only builds the string. But if that would be something more complex, I would make it like this. So I would make that from text a child of the hex, and then I would also make to text a child of string, something like that. So that would be this kid, a kid of a hex, and that would be the kid of a string. If that would be something more complex, but I don't need it because it's string is a string. It's quite primitive stuff. But if there would be something more complex, a bigger object, let's say a document, a user, or something else, then that would be obviously this guy would implement this type, and this guy would implement the string, the text. But the beauty of this approach is that I have everything, all the parsing, printing code inside one file, inside one big, entity. So I see in one page how it works, and there is no static stuff. And these two guys, they're perfectly legal, beautiful objects, which have just a constructor and one method just a constructor and one method. If, again, like I'm saying, if there would be a more complex entity here, then each of them would have a bigger amount of methods, because they would just inherit or implement the methods which would be coming from the type hex. Let me check your questions. Can't see the code. Okay, sorry about that. You're supposed to see. Let me check. I think you see me now. Yeah, let me check. Yeah, is it something wrong now with the... Ah, yeah, I get it. Oops. Yeah, that's my bad. So I was explaining... Oops, sorry guys. I was explaining something about this stuff. Let me show you. Yeah. I was talking about... sorry. I was talking about this, this class, and I was explaining that that design is better. So everything I just said before was related to this design. So look at it again. Let me repeat again. So we have this class hex, and I designed two classes inside. This one and that one. Let me show you. I'm sorry, I wasn't. You were not seeing my code before. So let me demonstrate. There were two examples. The first example was just was the wrong way. Well, not the way I was doing it before. But this is the way I'm doing it now. And let me show it again. So I have a string, which is how are you? And then I want to convert that string to hex presentation. So what I'm doing, I'm creating an object which encapsulates the text. And then that object is called hex. And then I'm using the method toS from that object in order to return the hex presentation of the string. And then in order to convert back, I'm using another object of another class, which is called toText. Well, this is just a compound name of the class. This one is called fromText, this one is called toText. And again, I encapsulate the hex form, and then the result is an object. You see, I'm not calling any methods here, and I'm not calling any methods here. So there's nothing here. I'm just instantiating an object, and here I'm instantiating an object. And then I just compare. Then at that point I'm calling toS in order to compare the results. So what I'm demonstrating here is that the parsing or printing, which is in this case is the same. So I'm taking the text and somehow parsing that what's inside and creating a new format of this data, is happening inside this object only when I call the method toS. So there's no static methods at all. I'm not calling any static here. And look at the design inside. So I have one class which is called hex. It could be a class, it could be a type. And I have two inner classes which are doing two things. This one is encapsulating the text and returning, when it's called, when necessary, it returns a hex presentation of the string. And here it's taking back the hex form and returns the string when toS is called. So I'm doing two operations in two directions. Printing, parsing, actually taking one format, converting into an object, and then taking that object and converting to the same format. And the beauty of this approach, when we are having two classes here inside, like inner classes, is that the entire functionality is right in front of me. So I don't need to have a parser and a printer and then somehow think how they will share some code. For example, some constants, some I don't know, maybe something which would be hidden here, some supplementary maybe classes, but which nobody else wants to see. So we have the code which is pretty related to each other. The parsing and printing, these functions, this logic has to stay close to each other. Let me check. Yeah, there's a question. Hex is just a namespace for the inner classes. Yes, in this example, it's just a namespace. But if that, like I was explaining before, if that would be a more complex structure, then I would do it like this here, and I would do it like this here. So that one, when I call it from text, it encapsulates the text and it implements the type which we want to be when the from text is instantiated. So there will be more, I don't know, more methods. For example, I don't know, my name, or there will be I don't know, my salary, if there will be something more complex. And here, of course, we would redefine them. We would put them here. So I would take the text and I would somehow parse it inside, and according to some my internal logic, I would return my name. I don't know. And then back, when I want to turn it back, here would be hex and here would be string, which would use that name, salary, and everything to print the string. No static stuff, no static parsing. So traditionally, this from text would be a static method, which would parse an object and return an object. I'm not doing that. I'm defining the way I parse is just the operator new. So there is no, look at this code, there is no point here where you can say exactly when and where the parsing happens. By looking at this code, you don't know exactly when this text is being converted to the hex. You see, it's not obvious for you. Maybe inside the constructor, maybe inside the method 2s, maybe somehow else. We don't know, because if there will be some code here, I don't know, something, another method. So maybe it happens here, or maybe inside 2s. So we don't know, and we don't care. We don't want to know that. That's the beauty of it. Because when you use parsing, the parser, the static method, if that would look like this, then we know exactly when the parsing is happening. It's happening here. There are a number of things which I have to mention why it's wrong. First of all, of course, we want to be in object-oriented programming, we want to be declarative instead of imperative. So we don't want programmers to know exactly when the computer, the CPU, is working on the data. We want to work on a higher level of abstraction. We just want to compose objects together, almost never worry about how they interact and how they pass data to each other. So we want to be less imperative and more declarative. This is absolutely imperative code. It just says to the computer, do the parsing right now, here and there. So we almost know down to the CPU operator, down to the CPU instruction, what exactly is going to happen there. Here, it's absolutely not like that. It's declarative. We just declare an object which is called hex, and we don't know what's going to happen inside. It's better. Declarative programming is better because it releases my mind, and it relaxes me, and releases my mind from thinking about what's going on in the computer, and I don't need to know all those details. It just makes programming makes programming easier comparing to imperative programming. That's first. Second, the beauty of this approach is that it's lazy. Like I said, we don't know when the parsing is happening, and because of that, it could be quite lazy. So for example, if here I say I raise an exception, then the parsing will not happen because it's delayed down to this line. So the parsing will happen if the object is designed correctly, of course. If the designer of this object done it right and doesn't do the parsing inside the constructor, then the parsing will not happen, and we will not take the resources of the computer. So we create an object, We just make an instance of a class, and then we raise an exception. But that's fine, because no resources have been consumed. But if we do the parsing here, then obviously exception is raised, but the parsing already happened. So we took the resources, we consumed some time, we spent some time on parsing, and it was a waste. Let me check your questions again. Yeah, the code, there's one comment here. So the code in the constructor is always bad. That's just bad. Another good question. So someone is asking in the chat, so why I'm using Parser in Zolt project. So let me get back to the Zolt project again, and I'll show you that there, it's another project now. So here, a similar problem, a similar piece of code. We also have something like parsing, some printing the numbers. So we're encapsulating the integer number here in the hex num class, and it makes the hex. It works perfectly here. So this first line is okay. It just makes an instance of an object. And here I'm calling the string. But then I want to parse it back. And I didn't know how to do it otherwise. I'm telling you, I was doing it for years, and I was always thinking that at this point, the static method parse is a legal case. This is how it should be done. There is no other option how you can do that. And if you look at the design of the class, you can see that this one class, only one, not two of them, but this one class, it encapsulates the number, and it can present itself as a string. But if you want to get it back from the string, then you need a static method parse, which will instantiate an object, encapsulate the number which was found during the parsing, and return an object. So that's, this self dot, meaning that this is the static method. I changed my mind. That's what I'm telling you. So about a month ago, I discovered that a better approach of two classes staying together in a bigger one. So we have a type, which is hex or user or some entity, some thing for the domain problem we're solving. In my case, is hex. And then inside that entity, we have two classes. The first one is, I'm calling them from text, and another one to text. So the from text is taking the, I'm switching the project now, is taking the text and presenting, because of this one means inheritance. So we implement the hex type, or inherit the class hex. So we are the hex. This from text is a class, is an instance of this class, is a text. Or if that would be, let's call it document. And then we may call it from JSON. You follow? Or let's say not a document, but transaction. Transaction. From JSON. And then to JSON. And then here would be JSON. That's how it would look. We have one class transaction, which may have other methods as well, or preferably that should be type, not the class. And then we have from JSON to JSON, from text to text, and they all stay together. And I see the code together. I see how I print it, and then I see it how I convert it back, parse it back. So getting back to why static code is not as good as objects. First one is, like I said, is declarative versus imperative. I think imperative programming is just more difficult for us to digest, to understand, to think, because we need to keep more information in our mind, in the brains. While looking at the code, we need to follow the instructions, and we need to think like computers. We need to follow the steps the computer is following, and it's not easy when the code is large. It's simple when the code is that small. Then you can look at it and say, okay, text is this, hex is this. Okay, I compare it, and then parse it for me and compare it again. But if the code gets larger and it takes like a few pages, then we don't want to keep that information inside our heads. We want to be more declarative. Second one is lazy. So this code is way lazier comparing to the static methods. When you call the static method, this is the exact point of time when you execute what you want to execute. So you ask the computer to run some code for you. And it's not lazy. If it's not lazy, you will have performance problems, and then you will have performance problems which are difficult to solve. It's not just performance problems, it's just a difficulty in solving them. Because when it's lazy, then it's easier to control the moment of when we actually execute, and it's easier to delay that moment. It's easier to optimize the code and execute things which need to be executed later, not earlier. And one more point, I think that it's in general when you have no static methods and you have objects, it's easier to test the code. Well, because static stuff is, like static stuff is global. So static methods can be called from different places in your code, and you have almost no control of who is calling them, because we are talking about public static methods. And when they're public, for example, in the case of parser, you have a parser who anyone can call. And if you're a good programmer, if you care about isolation of your code and decoupling, then your static methods will be thread safe and they will not clash if they being called at the same time multiple times. But in most cases it's not going to happen, and you will most likely, or sometimes, or maybe not by intention, but intentionally, of course, you will use some static variables as well. You have a static method, you need to keep some data somewhere, and you will use what? Static methods, static variables. Where else you can keep the data? And if you have static variables, you will get to the problem of sharing that data, of concurrency, of public visibility of that data, and then you completely get out of the object-oriented scope. You're absolutely back to procedural programming. So when you start testing that stuff, if you have static methods, it's difficult to, you may have problems with parallel tests and running tests in multiple threads. So that will definitely be a problem. But that's all philosophical. Not all philosophical, but that's just things which you may argue against. But now I'll give you the most important argument against static parsers and in favor of objects. I'll give you another example, which is a bit larger than the one you saw before, and that's again from the Zolt project. Let me check the chat. Okay. Yeah, you can see the code now. Let me open a bit bigger one. This one is an HTTP page, an abstract for an HTTP page. So it's a class which is, let me show you the unit test for it, and you will understand how it works. For example, this one. I say this one. So I say Zolt HTTP new, and then I provide the address, and then I provide some supplementary parameters. And this is how it works. So first I create an abstraction for the web page with a certain address. And then what I'm doing, I'm calling the method get, which is basically HTTP get, in order to return the HTTP response. And then from that response, I'm saying response.code in order to return the HTTP response code. This is how it works now. And the problem with this stuff is that even though we have no static here, it's still not it's still a parser, sort of a parser. So it's the same design. It's still the same or very similar design approach, because we have the method get, which returns the response. So instead of doing that, this get could be, we can replace that that get with something like, I don't know, we can say HTTP get and parse HTTP page, and then we give the address. It's almost the same, because the result we're returning, what this get method should do, it should go to the web page, get the data from there, and then build a new object with the result inside, the response object, and return it to the user. So this is some sort of this response is a sort of a data transfer object, because all it does, it transfers the data. And this is what's wrong, because the real information, the most powerful, the smartest entity in this operation is this object. This object contains the logic of how to, here's the method get, of how to make a connection to the HTTP or HTTPS, how to configure this timeout or not timeout, how to configure the path for the request, and then how to get the data from there, and even how to parse the data. What this object knows, the result, it's just a data transfer object. It's a pretty dumb data container, which we need to fill in here. We need to inject all the information into this container and then return the container to the user. And at that point of time, we break the connection between the user and us, who knows so much about how to get the data and how to parse the HTTP page and how to work with the HTTP page. We just disconnect these two guys. The receiver of the response will only get the stupid, anemic, no functionality inside, just a data container, which, in order to be smart enough, in order to give enough information to the receiver of this container, we need to make the container as large as possible. To make it as large as possible, what do? We need to parse everything we can get from the page. All the necessary details, all the headers, all the status codes, the entire page, and then put everything into the response object, which is, of course, waste of time. But the biggest problem is that it's lose of control. We lose the control. We don't know when that data will be required, who is going to use them and how. Instead of letting those clients and those classes and those people talk to us directly, to us I mean to this HTTP object, we are just giving them the piece of data which they need to deal with on their own. And they have no connection afterwards with us. That's the problem. That's what this design, why this design is wrong. And let me show you how I face the problem practically. So I had this is my code. So I had this get method, I had this put method, get put, and then I started to realize that sometimes the get method may fail. Sometimes I'm getting, I'm connecting to the HTTP page somewhere, and I can't establish a connection, or there is a timeout, or something else happens. So what do? I still want to return. I don't want to throw an exception. That was my business requirement. So I don't want to throw an exception. I want to say that something is wrong and bubble up this problem to the highest level. No, I want to swallow the problem, to swallow the exception, and return the user an error page. So that was my business requirement. So every time you're trying to get something from internet and it doesn't exist there, I pretend that it was there, but there was a mistake. There was an error on the server. So I want to return an error page. So like the 404 page when the the resource is not found, something similar should happen here. Instead of exception, you should get a response which says that the data is not there with a special code like 503 or 500. So what I did is I catch the exception here, and then I need to return something. This method from Ruby returns a normal data transfer object with everything inside, with the code of the response, with the message, with the body, with everything. I needed to return something else, something custom. And I created a custom object, my own stuff, a private one. Here it is, the class error. And I had to put all the methods which a normal class would have from Ruby into my fake class, which pretends to be the broken page on the internet. You see the code I'm returning, find 599. So I just made it up. I decided to use this code. So you see, this is data transfer object, as pure as it is, because it contains the very silly static data, not static in the way static methods are, but they're not dynamic, they're not runtime, they're not coming from runtime. They are just staying here inside, and they are pretty much detached from the code here. So that this code, this method, knows what's going on, knows what the problem is, and maybe even can try to retry the connection. But here I cannot do that because it's already fixed. These data are fixed. So I cannot, for example, say that when somebody is calling the code and the code is 599, I want to retry a few times. It's not possible because there is no code inside here. It's just a data container. If, for example, that somebody is taking the message and I want this message to, when the message is this and that, then I want to, I don't know, reconnect to the server or maybe submit something back to the server. I cannot do anything like that. This structure is absolutely, it's absolutely dead. There's no behavior inside. It's just plain stupid data. If the design would be different, it's my fault. I made this design, so I'm just analyzing what I did, and I'm saying that would be. It's possible to make it better. The better design would look like this. I would say HTTP new, same address. And then instead of doing this, I would just say, give me the code, or give me the body, or give me the message. You see, I'm just skipping the step of parsing, of fetching the data, and I'm just saying, give me the code. If I wanted to make get, then I set it get here, or I put here, and then I just say code. So I'm making it more declarative. Instead of doing get, which explicitly says that, okay, now get what you have to get, and what you return from this get is a data transfer object. And then I'm taking code from it, but it's too late. Instead, I'm saying, look, give me the code. The page, the HTTP abstraction. Give me the code. And if I do it that way, I would not need that stupid class to look like this. It would look completely different. First of all, it would go away for sure. And second, I would be able to use decorating in this case. I would be able to decorate my code with, instead of catching the exception here, I would just, in order to make it safer, I would design it like this. Like this. So this class will not know about exceptions at all. It will throw exceptions if something goes wrong, but this one will catch all the exceptions and return 599 if they happen. It's easier to decouple them. It's easier to break them down into pieces. It's easier to use decorators now, and that would be a much better object-oriented approach. I didn't do it, my fault, but that's how I'm suggesting to go for object-oriented approach. And it's all about parsing this or that, because this one is definitely a parser. So what it does, it takes the string, it takes the content from internet, from somewhere, and parses it and returns code, message, body, and headers to 4 pieces. It just breaks down what's coming in into 4 pieces of data, 4 pieces of information. And we can, like I just said, we can either parse it and return a plain, a silly and very plain object, or we can be more object-oriented. So that's the main point why parsers, parsing objects are good, and parsers, as static parsers, it's a bad idea. And now let me check your questions, and we will be finishing. Yeah, we have some Russian text in here. I'm gonna skip that. What do you think? The question is, what do you think about declarative lazy languages that are not object-oriented programming? I don't know what kind of languages you're talking about here, but declarative lazy languages, it's like functional programming, yeah, like functional languages. I think that that in general, lazy approach and declarative approach is just better than than imperative. That's it. So that's let me check another question. I'm reading your questions now. One comment is, basically in any well-written application we have 2 parts. One of them is procedures or static methods, and declarative part that contains elegant composition of objects. Well, unfortunately, we may have that stuff. Yes, we may have a combination of pure object-oriented stuff and something which is quite far from object-oriented. But like I just demonstrated to you, I have it in my code as well. So sometimes it's inevitable, sometimes it's just faster, sometimes we just used to think that way. Like I'm used to think, when I was starting to design an application, I just needed some code which will somehow fetch me the data from internet and return me something which I can then parse and interpret like JSON, for example. And then I did it like I was doing before. Okay, it's HTTP, okay, we have 2 methods, get and put. And that was a mistake. Like I'm realizing it now, and maybe we'll refactor it for later. But unfortunately, I'm also used to procedural programming, and I'm thinking initially when I start designing, I very often think in a procedural way. I think how to do that task, how to what code has to run in order to achieve the result. So instead of thinking on a higher level, I'm thinking on a lower level. I'm thinking about how to fetch the data, what operations needs to be done. And then I start wrapping it up into classes and classes and classes. What I end up with is just procedural code. Just procedural code in containers. But it should be a different mindset. We should start thinking from a higher level. We should look at the problems we're solving and say, okay, what do I have to have? I need to work with the HTTP JSON page, with the JSON page coming from HTTP. And okay, call it JSON page, or call it HTTP page, or call it just page. So then what do you need from that page? I need a code, I need a headers, I need a collection of headers. And then you go deeper, and then you go one level deeper, and then you go down to implementation. And then you will implement it. That's how you will get the code I just showed you. That we will have the this one. We'll have this line. So in order to get to that line, I need to think from this level. I need to think from the level of the class, from the level of a problem, instead of start thinking about that, or even worse, from how do I get it. So give me the data, wrap it up in a package, give me the container of data, and then let me deal with the data. So that's the key problem with parsers, because parsers, they parse and return you the data. They return you the container of information, and then you deal with that information. And then you need to re-implement the entire logic. You need to think what to do with that, like I'm thinking what to do with the code here. It should be not like that. It should the parser, the code which parses something for us should not return what's parsed. It should become what's parsed. It should become the HTTP page for us. It should become the user for us, or the transaction, or the document. And everything which relates to parsing will be encapsulated in the in that entity. Yeah, let me answer a few more questions. Do you think, another question, do you think that in general it's impossible to get rid of static methods at all? Because if we want to create object-oriented from scratch, we need to base our objects on system calls. Well, that's a good question. So somehow some static stuff is probably inevitable in languages like Java or Ruby, because the libraries, not, we're talking about system calls, but I mean, it's not about system calls, it's about more like libraries and frameworks they provide to us. So the libraries they have, they all are polluted with static methods in Java, Ruby, many languages. And that's why we just cannot, we cannot just stay completely object-oriented and completely static methods free, because we are connected to the libraries we are supposed to work with. So that's why it's inevitable. But I'm suggesting to always stop and think, like I did with my example. Stop and think when you're using a static method. So take a pause and think, is it possible to get rid of that? I was thinking for a few years about that. And finally, I'm saying you, just a month ago, I found a solution for this parsing, and now I'm happy. So maybe that's the good finishing point. I would recommend you to the last one question is why you use parse in Zold, because I was doing it half a year ago. So I did that half a year ago, and that's how I did it. I was doing it in many projects of myself, not only in Zold. In many of them, in Java and Ruby, I was always thinking that this .parse is an inevitable approach. You just can't do it otherwise, because in order to keep the code together. So if you're ready to move your code to two different places, then okay, you can get rid of the static method. In one place you will parse, in another place you will print. But if you want to combine the printer and the parser, then one of them will become static. That's what I thought. But now I understand that you need just put them together into one bigger class and make them inner classes. And that will solve the problem. Thank you very much. We're running out of time. It was, I think, quite difficult webinar for me, because it was difficult to express all these thoughts. But thanks for joining. I'll see you next time. We're trying to make it every first Wednesday of each month at 11 in the morning Pacific time. Thank you very much. Bye-bye.